Hello all researchers and participants. I am Ceren Bayraç from Bioengineering Department of Karamanoğlu Mehmet Bey University. I am very pleased to share with you my presentation entitled as Evaluation of DNA Extraction Protocols from Cottonseed Oil. The increase in the production of processed food and packed food in the food industry with the increase in population and the increased awareness of consumers regarding the composition of foods highlighted the need for more stringent food quality control. And when we think about the food quality control, we should especially evaluate the determination of the origin of the products, the determination of the raw materials used in their production, and the verification of the authenticity of foods. Many international food standards are imposed by countries to control each step in a food production process to ensure the food safety. The origin of the raw materials and products is a kind of guarantee directly for food safety and human health. This is especially valid and true for vegetable oils, where their raw materials, origin, and their production process indicate the quality of final product. The cottonseed oil is an increasingly important product due to its nutritional value, which is obtained from the seed of the cotton plant. The cotton ranks fifth after soybean, palm, rape, and sunflower in terms of oil production, and second after soybeans as a protein source. And as you can see, a cotton plant consists of seed and fiber, and 57 of the cotton seed is seed pulp, which is used for feed. 10% is cellulose, which is used in paper industry for the drug capsule production and diaper, and 10% is seed pod, which is also used for feed, and approximately 18% of cottonseed is oil. The oil content extracted from cottonseed differs along with cultivars and geographic locations for cultivation. Once processed, cottonseed oil has a mild flavor and becomes light golden yellow in color. The color tone varies depending on the processing and refining process, and cottonseed oil is commonly used in processed foods because of its ability to extend the shelf life. Some of these products include, as you can see, potato chips, cookies, margarine, mayonnaise, and salad dressing. Several studies have been carried out that report the authenticity assessment of vegetable oil and especially for olive oil for a long time. Many of them are based on physical chemical parameters such as free acidity, peroxide value, and fatty acids. These parameters have been analyzed mainly by chromatography systems such as HPLC, GC, and GCMS, and also by spectroscopy like UV spectrometer and FTIR. Although these techniques have been routinely used for the detection of authenticity, they do not provide reliable results for oil traceability. Detection requires rapid and reliable screening, simple sample preparation, and easily available reagent. Recently, DNA-based methods have been widely applied for the differentiation and identification of components in food. Their use in oil characterization offers many advantages since they provide higher specificity, sensitivity, and repeatability. The first and the most important step in DNA-based molecular studies is to obtain intact DNA with high purity. The basic principle in the DNA extraction procedure was the breakdown of the cell wall of vegetative cells if it's a plant, and cell membrane disruption using detergents such as CTAP and SDS, thereby releasing DNA molecules in the cell. The success criteria in DNA isolation are the amount and the quality of DNA, and they are mainly affected by the extraction methods and matrix itself. There are various studies in literature in order to develop DNA isolation methods for oil samples and to provide pure, high quality, and enough amount of DNA for further studies. Although DNA extraction methods for cottonseed samples were studied frequently, there is only one reporting DNA extraction from cottonseed oil samples so far. This study compared the CTAP-based method with FPLC-based method for the purity and applicability of DNA for PCR. Within the scope of this study, DNA isolation from cottonseed oil samples was performed using three CTAP-based DNA isolation methods previously determined for olive oil in literature, and the general DNA isolation kit developed for DNA isolation from foods. The concentration and the purity parameters of DNA obtained were checked with a spectrophotometer. We used 8 cottonseed oil samples collected from Adana region of Turkey, and as you can see, for 3 manual CTAP methods, we prepared extraction buffer solutions. We used ImmunoPrep food DNA kit with the automated DNA extraction instrument also. For concentration determination and quality control, we measured the absorbance values of DNA samples at 260 nanometer and calculated their concentration by the following formula. For DNA purity analysis, we compared the ratio of absorbance values at 260 nanometer to 280 nanometer, and for pure DNA, the ratio should be within the range of 1.7 and 2.1. For each cotton oil samples, 5 biological replicates were used in each extraction method, and triple measurements were read for each replicate. All results were given as mean and standard deviation. When we came to the result and discussion part, we see a table showing minimum and maximum amounts of DNA extracted by each method from 8 oil samples with 5 replicates, and the last column indicates the number of samples with acceptable purity values. With the use of first CTAP-based DNA isolation method, the maximum amounts of DNA extracted from cottonseed oil were found as 58 and 63 nanogram per microliter for 300 and 500 microliter initial sample volumes respectively. CTAP methanol extraction-based method yield DNA amounts within the range of 3 and 48 nanogram per microliter from cotton oil samples. In the last manual method, the maximum DNA concentrations were obtained as 143 nanogram per microliter and 42 nanogram per microliter for 300 and 500 microliter initial sample volumes respectively. Commercial DNA isolation kit yield a lower amount of DNA from oil samples as compared to the manual CTAP-based methods. Maximum and minimum amounts of DNA were found as 12 and 0.6 nanogram per microliter. If we compare the mean, standard deviation, and CV values of DNAs extracted from 8 oil samples, we observe that among these samples, closer concentration values for DNA were obtained again by a commercial kit with highest CV values of approximately 2.1%, while the concentrations of DNA obtained by CTAP hexane chloroform-based method showed variance between the 8.6 and 66%. The results of DNA isolated by CTAP mercaptoethanol-based method showed variance between 24 and 89%. These results are also shown with this graph. Commercial kit gave better results for repeatability with lower error bars on the graph, as you can see. Although the mean concentrations of DNA extracted by 3 manual methods were higher, standard deviations of the measurement were also higher for all 8 oil samples. In order to have higher yield and to remove undesired molecules such as polysaccharides, phenols, and proteins, DNA samples were purified by ethanol. This table showed DNA concentration and purities of the extracted and purified DNA samples in the study. Although there are a slight decrease in the amount of DNA due to the washing step with ethanol, the purity of DNA extracted from cottonseed oil samples by 4 methods was increased as seen in the table. Since the concentration of DNA samples were higher as compared with the other methods, the DNA samples extracted from 8 oil samples by C-type-based method were also visualized by gel electrophoresis to control the fragmentation of the DNA molecules. As we can see from this image, all DNA samples are intact after ethanol precipitation. As a conclusion, in the study, DNA isolations were carried out with 4 different methods from commercially available cottonseed oil samples. C-type-based manual methods yield higher amount of DNA as compared with the other methods. However, the repeatability of DNA extraction methods was higher by the commercial kit. Although the concentrations of DNA were decreased slightly for all samples extracted by 4 methods, DNA became more pure after ethanol precipitation.